Hi and Assalamualaikum. My name is Nurhayati Binti Saggaf al Junid. Today I'll present to you a review on antioxidant activity and medical value of selected ananas species. Let's move to background and problem statement of this study. During cellular metabolism, free radicals are generated, which cause the damage of cell and lead to health issues. Free radicals are classified as highly reactive molecules with one or several non-paired electrons. Ananas commerces, which also commonly known as pineapple, belongs to the bromelain's family, which contain bromelain, which serve as free radical scavenging of reactive oxygen species. Next, let's move on to the significance of the study. Due to the poisonous effects of synthetic antioxidants, our study will compare the differences between the ananas species as alternative source of antioxidants from natural sources. Also, this study will compare the difference between the ananas species variants in various aspects such as their photochemistry. Various extraction procedures of different ananas species will also be compared. There are 5 objectives of these studies. The first one is to compare the effect of different solvents and concentration on the extraction of phenolic compounds from pineapple. Next, to compare the difference between pineapple variants in terms of their phytochemistry constituents. Next, to compare influence of temperature and duration on the extraction pineapple species compounds. The next one is to compare the differences between the pineapple variants in terms of their Next is to compare the differences between the pineapple variants in terms of their antioxidants activities. The last one is to identify the components contained in ananas that can treat several diseases. The first point of literature review is extraction of pineapple. Method of extraction, different solvent, solvent concentration, contact time, extraction temperature are all parameters that affect extraction effectiveness according to Rashid et al. While according to Dye Mamber, methanol, ethanol, and acetone have all been suggested as good extraction solvent. And Simcoe et al. Reported that extraction is added by high temperature. Figure 2.2 illustrated the total phenolic content yields of methanol at various concentrations. It shows maximum amount of phenolic compounds, which is 102.86 mg, and study by Salema reported the most efficient solvent for recovering methanol chemicals from pineapple was methanol at 80% concentration. Next, let's move to effect of extraction time. The total phenolic content is shown in figure 2.4 at various extraction time. At 90 minutes, 98.85 mg gallic acid equivalent per 100 gram fresh weight fruit was the total phenolic content. As the extraction period increased, the mass transfer rate increased, allowing the solvents to extract from the solid before the equilibrium is reached. Let's move to the next main point of literature review, which is bioactivity compound of pineapple. Pineapple's bioactivity is attributed to the existence of chemicals like polyphenols and ascorbic acid, according to Hossein and Rahman. Phenolic compounds, which are antioxidants that are more effective scavenging free radicals. There are abundant phenolic compounds in pineapple, according to Haripre et al. Table 2.2 shows the bioactive component also contain variation pattern of several pineapple genotypes. The findings by Syed et al. Demonstrate the phenolic chemicals are genetically regulated. Catechin, epicatechin, and synapinic acid were the most prevalent phenolic compounds in the pineapple sample studies. Next main point is antioxidant. Antioxidant is any molecule that has the ability to deactivate the free radicals to prevent the harmful effect to the cell, according to Rahal et al. The damage becomes massive when antioxidant is limited in the body, according to Barber and Harris. Based on previous study by Ferreira et al., the vitamin C content of the study's varieties range from 35.88 to 62.11 mg per 100 gram, with Imperial cultivar having the greatest concentration of vitamin C, phenolic compounds, and antioxidant activity. This outcome was identical to rum syrup and SOLVENT research.
Next main point is this study is total phenolic content. The presence of phenolic compounds can be used as a preliminary screening strategy for substance that will be used as a natural source of antioxidant food, according to Rashad et al. The following QCAL2 method was utilized to identify the total phenolic content of pineapple samples in Songs et al. Studies. The most total phenolic was found in MD2, followed by fresh premium and smooth canine pineapple, according to Song et al. Research.
2.5 shows the total phenolic content of a methanol extract of fermented pineapple waste at diverse doses. All were greater than unfermented pineapple waste extract, according to Rashad et al. Studies. At 8 mg per milliliter concentration, the fermented pineapple waste extract had the greatest phenolic content, while the unfermented waste pineapple extract had the maximum phenolic content at the same dosage. Next point is ascorbic acid content. Ascorbic acid is a cofactor in many plant deoxygenase, and it is one of the most abundant antioxidants in nature, according to Solomon, George et al. The ascorbic acid content of the ananas type differ were shown in table 2.5. The ascorbic acid content in MORIS pineapple was the highest with 27.8 mg per 100 gram fruit compared to Sarawak and Josephine. This is antioxidant activity, NANGLAE and PHULAE pineapple. To determine the antioxidant activity of pineapple extracts, DPPH method is used as it is sensitive, rapid, and easy method, according to Subterranea et al. Pineapple with higher TPC level, like the PHULAE, exhibit poorer DPPH scavenging ability than pineapple with lower TPC levels, such as NANGLAE, according to Kongsuwan et al. Next is about Sarawak, MORIS, and Josephine pineapple. Based on research by URIS and SO, it was also discovered that Josephine, who has the highest TPC but the smallest ascorbic acid covalent antioxidant capacity, it is likely that the pineapple extract phenolic component interacts slowly with DPPH radicals, result in the small ACAC readings, according to Liu et al. Studies of Solomon, George et al. Reported as the fruit matured, the overall polyphenol content decreased significantly. Similar to Wang et al. Research found that phenolic chemicals decrease as the fruit matured. The optimal time to harvest the Sarawak pineapple is when it is in stage 4, as the total antioxidant capacity is the highest. Next, let's move to fermented and unfermented pineapple waste. As shown in figure 2.8, at a concentration of 8 mg per milliliter, a progressive enhance in scavenging activity was noted, reaching a greatest of 86% for unfermented pineapple waste extract, while 97% for fermented pineapple waste extract, with a decline in their activity beyond this concentration. Fermented pineapple waste had more antioxidant component than unfermented pineapple waste. Next point is about bromelain's effect on diseases. Pineapple contains bromelain, which is important as an antioxidant, anti-cancer activity, anti-inflammatory, and cardioprotective agent. The conclusion of this review paper is the best solvent for pineapple phenolic compound extraction was methanol at 50% volume per volume extracted. The temperature of 35 degrees Celsius at 90 minutes was shown to be more efficient for extraction. The MORIS ananas extract exhibited the greatest antioxidant activity as it has the greatest scavenging activity, and bromelain in pineapple is an anti-inflammatory that reduces swelling in inflammatory disorder. The recommendation of this review paper is the oxygen absorbent capacity assay and the ABTS radical
Patients. Scavenging assay can be used to learn more about the antioxidant activity of pineapple extract.
Next, pineapple-related research and development should be implemented widely in a variety of disciplines as well as machinery, agronomy, disease, and pest control. That's all from me. Thank you for your time.